Look at these numbers. Obviously, it's a nice sequence. What you see are natural numbers. But if you look at them carefully, there is a lot more we can get out of these numbers. In this sequence, every number is one more than its previous number. You agree with me? 2 is one more than 1, 3 is one more than 2, and so on. Let's look at a series of odd numbers. 1, 3, 5, 7, 9, and so on. Now, what can you say about this sequence? Once again, there is something beautiful about it. 3 is 2 more than 1, 5 is 2 more than 3, and so on. So, whenever we have such sequences where every number is a fixed number, say k, more than its previous number, well, they are called arithmetic progressions. So let me define it for you. Listen carefully. An arithmetic progression, and I'll call it AP hereafter, is a sequence in which the difference between two consecutive terms is constant. I can give you other examples as well, like sets of whole numbers and integers. But let's look at an interesting example. Let me write a 7. Let me write another 7, another 7, and a sequence of 7s. Do you think this is an arithmetic progression? Let's apply our basic test. Find the difference between two subsequent terms. 7 minus 7 is 0, 7 minus 7 is 0. Well, 7 minus 7 will always be 0. But it is still constant. Every time it is 0. So if the difference is constant, it has to be an AP. Let's look at one more example. For a real number m, does the sequence m plus 1, m plus 2, m plus 3, m plus 4, and so on form an AP? Let's apply our test. Difference between the second and the first term, m plus 2 minus m plus 1. M gets cancelled and we have 1. Now let's find the difference between the third and the second terms. M plus 3 minus m plus 2. Once again 1. Fourth and the third terms. Once again 1. Since the difference remains constant, that is 1, this is nothing but an arithmetic progression. So don't forget how to find whether a given sequence is an arithmetic progression or not.